That means basically when they're talking about minimum and maximum, that means indirectly you need to like understand that they're talking about elliptical orbit only. Sir, elliptical orbit means, see here what will happen. So it will be at one of its focus. Minimum distance is given as what, sir? 2r, and maximum distance is given as what? What's the value? Maximum distance 4r. So this is 4r, 2r and 4r. Now what they were telling? So after 2r and 4r, so they're asking us to find angular momentum. Okay, and what else they give? The radio. So now the minimum and maximum distances they gave. Fine. So angular momentum of a satellite about the center. So you guys know angular momentum will remain what, sir? Constant. Okay, that is what Kepler's second law is. dA by dt equal to constant, which is dA by dt L by 2m. Angular momentum remains constant. So actually you guys can find any like angular momentum at any point, and that will be the angular momentum in the entire like what, sir? Orbit. So first they are asking radius of curvature, angular momentum. So all those things they are asking. Okay. First let me consider this is capital M. Okay. And here let's say small m mass is rotating. So now you guys can tell like what is the potential energy of the particle at this point? Can you guys tell? Potential energy between two masses. U can be written as minus G m1 m2 by distance between them is 2r. Is that clear? Minus GM1
Yes,
minus
sir.
GMM by 2R. And you guys know how to write kinetic energy when you know potential energy? You know how to write kinetic energy when you know potential energy? Or else we'll do one thing. Okay. Radius of curvature, what I need to find? The angular momentum only, no? So that means basically I need to find velocity at this instant. mv square by r. So if this is potential energy, so tell me what will be the kinetic energy? So it will be there in modern physics also. Very, very important. No relation between kinetic energy, potential energy, and total energy. What is the relation you guys know? Magnitude wise, total energy will be equal to kinetic energy will be equal to half
Half
of
of potential energy.
potential energy. This is very, very important. In modern physics also this helps, no? So the same thing in like gravitation or electrostatics, wherever something is doing orbit. Okay. So remember, this is a relation for total energy, kinetic energy, and potential energy. Once you know the potential energy, so tell me what will be the kinetic energy from here? Half of that, no? So kinetic energy will be how much? Magnitude wise, gmm by 4r, which I can equate it to what? Half m, which I can equate it to half m v square. So half mv square is the value, right? So once you get half mv square, just equate these two. Then what is the v value you're getting? V equal to under root of gm by 2r. So once we get the v value, okay, once we get the v value, so what about angular momentum formula? Angular momentum is m into, what is L, sir? M into r perpendicular into v. So r perpendicular in this case is simply 2r. So small m into r perpendicular is 2r into orbital velocity is under root of how much? Gm by 2r. So what will be the answer? Total answer, final answer. If you just take it inside, what you're going to get? 2 Gm small m square r. So this is the value you're going to get. Clear? So first I found the potential energy. From potential energy I found kinetic energy. And from kinetic energy what we have found? Velocity. And from velocity we can find the angular momentum.
Sir, but it option it is 8 by 3.
No, 1 second. Let me do maximum minimum speeds. Option A is given now. Maximum minimum distance of satellite from the center of the 2R and 4 respectively. What is the radius of the Earth? M is choose. Angular momentum of the Earth is 1 second. V max, V minimum. What are the things they are asking? It's minimum speed, maximum speed. Okay, 1 second, 1 second. My bad. So let us take the elliptical orbit. Elliptical orbit. Here, let us take this as 2r and this is given as 4r. No. So we know if it is closest, the speed will be what? Maximum. So here I am taking it as V min. Let me take the speed as V min. Sorry. It will be maximum. No. V max. And here let's say the speed will be V min. So how many unknowns we are having? Two unknowns. No. So we are having two unknowns, so we need two equations to find this one. So what are the two equations that I'm going to use is, first equation is angular momentum conservation. So that is here m times 2r into v max will be equal to what, sir? M times 4r into v minimum. Okay. And then here what will happen? So from here you will be getting v max equal to 2 times v minimum. V max equal to 2 times of V minimum. So this is one equation I got. So equation number 1. But we need one more equation, right? So because two variables are there. What is another equation means? Total energy of the satellite will remain constant. Okay, total energy of the satellite will remain constant. So if the total energy of the satellite remains constant, so let us see here what you're going to get. Let's say I call this point as A, this point as B. Energy at A must be equal to energy at B. Sir, what is the energy at A? What is the total energy at A? Kinetic energy will be there as well as potential energy will be there. Kinetic energy is what? Half m V max square plus potential energy will be what, sir? Minus G capital M small m by 2r, which is equal to half m V minimum square. And here what is the potential energy? Minus GMM by how much? 4r. Now, okay, in the question, what they're asking minimum speed only. No, let us find eliminate maximum speed. Sir, how to eliminate maximum speed? V maximum is 2 times of V minimum. Let me substitute here. Then how much you are going to get? Tell me. M by 2 times of this. You will be getting 4 V minimum square, and this V minimum square I'm getting the left side. So minus V minimum square. So which is equal to what is GMM by 2R minus GMM by 4R? GMM by 4R. Now from here, see small m will get cancelled, and this is how many times? 2 times. So therefore from here what will you get, sir? From here I guess you guys can find V minimum. So 3V minimum square will be equal to GM by 2R. GM by 2R. Therefore V minimum equal to how much, sir? V minimum equal to root of GM by 6R is the V minimum. Is it clear? V minimum. Understood, no?
Yes, sir.
Once we get V minimum, now we can find angular momentum. No, just now I told you at the starting, according to Kepler's law, second law, angular momentum at any point is same. Here you find, or here you find, or here anywhere it's same. So let me find angular momentum at this point. Sir, angular momentum at this point is given as what, sir? L is m into r perpendicular is 4r into V minimum. V minimum is this value. What is this value? Root gm by 6r. So let me bring everything inside. Then 16 by, it will go inside 16 by 6 under root of G capital M small m square into R, because one R will be cancelled. So this is how many times? 2, 8. So 8 by 3 G capital M small m square R will be the answer. Clear?
Yes, sir.
Now total energy. How to find total energy? Total energy you can substitute anywhere. No, let's say here if I substitute here, I'll be getting the total energy. So what is total energy? Half m V minimum square. What is V minimum square we got? GM by 6R. No, GM by 6R minus GMM by How much you got? GMM by not 2R. What is that? 4R. GMM by 4R. So if I take GMM by R common, what is left out, sir? What is left out? 1 by 12 minus 1 by 4. What is the LCM I can take? 12 I can take. 1 minus 3. So minus 2 by 12. Minus 2 by 12 means what? Minus 1 by 6. So answer is minus 1 by 6 GMM by capital R. Is that
Sir,
clear?
how? Yes, sir. Sir, how to find radius of curvature in this question?
Radius of curvature where you want to find at minimum distance here, no? See, this will be there in kinematics also. Okay, that also I'll just tell now. Sir, how to find means this is like first of all try to think about why this satellite is rotating. This satellite is revolving only because of gravitational force that is given by the Earth, right? This is because of gravitational force that is given by the Earth. Sir, what is that force at that instant? Can you tell? Force at that instant is GMM by R square. That is G capital M small m by 2R whole square will be equal to MV minimum square by R 2R. So this will be the answer. Sorry, MV square by not 2R. Don't take 2R. R is not the 2R is not radius. That only we need to find. This is the radius of curvature. Let me take it as R naught. This is our radius of curvature. Radius of curvature is it will be something like this. You are going to find radius of this one. How to find, sir? Net force towards center is a centripetal force, which will equate it to mv square by r, and you will get the radius of curvature. So this m will get cancelled. So when you just substitute here, you are going to get the answer. See here, if you want, we can just verify. What will you get? Gm by 4r square, which is equal to v minimum square. Just now we found. No, what is that? Gm by 6r into R naught. R naught. So GM will get cancelled. So R naught equal to 4R square by
Sir,
huh.
it's not the V minimum. It's should be V maximum.
Okay, my bad. Then it will be twice, no? So because here I am finding here, yeah. So it will be V max means twice of that. So twice of that one means 4 you will be getting. Extra what will be there, sir? 4 times of that. So 4 times of that means 4 into 4, 16 by 6. So what will be the answer? 8R by 3 will be the answer. Clear, no?
Yes, sir.
Hmm.
Third question.